Moreni, welcome to Mr. Kolosa's online extra classes. And today you are taking a look at physical sciences. We're doing past papers to be specific. But now in this video, we'll be focusing on momentum and impulse, which is the first topic in physical sciences. Like it's in term one. So it's a term one topic. But now we're just doing question papers. So it means if you're watching this video, I'm assuming that you already understand the theory behind momentum and impulse. So please note that this video will be in Isixhosa and English, but most of it will be in in English. And then here and there you'll hear me in this Isixhosa Panapa. Okay, so we're taking a look at the question paper from March 2017 with 2017. So this is a common test from a KZN. Then Zalendo saw that if ufuna ifumana le question paper online, if you want to see where I found this question paper, so you can locate it at testpapers.co.za, or you can also find it on my website, which is Mr. Kolosa extraclasses.com. So you can find that this question paper. Okay, but today we're taking a look at question 4, which is momentum and impulse. Okay, so let us say mhlambi ukoweni, you're trying to practice question papers and you come across this question paper and you also have the memo, but still the memo, there's something that doesn't make sense as to how they got the answers. So this is the video that will help you understand how answers are obtained by the memorandum. Okay, this video will be very useful, especially when you're trying to practice on your own at home. So this is kind of a guide into all the memos. This is the video number 1. Of course, there's other videos as Zaulandela on momentum and impulse. Okay, so every time we read a question paper, every time we encounter a physical sciences question paper, we first read a statement and then we collect data and choose the direction. Okay, so let's read the statement and choose direction and collect the data. That's the first thing. So they're saying here, a car is traveling eastwards along a straight road. So it means this car was originally moving to the east. So we can take east as positive because it's the original direction of motion. If there's a vector going to the west, we will give it a negative sign. I hope that makes sense. Okay, now the driver sees an obstacle across the road and then applies the brakes. Once applied, the brakes allow the car to slow down. Unfortunately, this is not sufficient and the car crashes into the obstacle. So in other words, can't be enough as a brakes as apply lay, and then wachai is meaning the car collided with the obstacle, and we're told that the car hits the obstacle with a speed of 4,674 meters per second. That is the initial speed or initial velocity to hit the obstacle. So we collect that because it's very important. So V initial is 4,674 meters per second. That is the initial velocity to strike the obstacle. And then they say that it takes 0.2 seconds for the car to come to a stop. So in other words, it takes a time of 0.2 seconds to reach a final velocity of 0. It means to come to a stop, or sometimes to become at rest. At rest and to come to a stop is the same thing. It means the final velocity became 0 meters per second. I hope you understand those things. In physics, when they say an object is at rest, it means immediate, or it's stationary, it means the initial velocity is 0. So if it collides with a wall or an obstacle and then ends up coming to rest, it means it stops. It has a final velocity of 0. I hope that makes sense. And they say that the mass of the car and the driver is 1,100 kgs. So we are also given the mass of the car and the driver. So the mass of the car and the driver, because we treat the driver and the car as one object. So the mass would be 1,100 kgs. Okay. So we have collected our data from the statement. That's the first thing that is important. Secondly, we have already chosen a direction for this question. Okay, we're sorted. Now we can approach questions all the time. Okay, now let's go to 4.1. 4.1 says define the term impulse. Remember, I said you already know a theory. I'm assuming that you already know the theory um, on these question papers, or sorry, on the theory on this topic, which is momentum and impulse. If you're not aware of or you don't understand the momentum and impulse, and then you feel free to go and check on videos on momentum and impulse. If you're watching this video from my channel, which is Mr. Kolosa Extra Classes, then you will see Gepagwi channel playlist. You will find a momentum folder whereby you can watch the momentum theory. If mhlawumbe ibukele kwi-website yam, I'm sure you can navigate onto the website, and then you will see tutorial videos, and also you will see the theory, because zonke izinto phaya ndiyazikhaverisha, and it means that I also cover everything, or all the theoretical momentum and impulse. But now we're just focusing on equation papers. We're not going to focus more on the theory. I'm not going to try to teach you, but I'll try to explain why we're using, why we're doing what we do. Ne? Okay, define the term impulse. Well, impulse is the product of the net force and the time taken by the net force to act on an object. So in other words, see a city class impulse, we even say we give it a symbol of a change in momentum. We say impulse is F net times delta t. So this was the formula to calculate impulse. But we're defining impulse in words as the product. So it's the product of the net force, the product of the net force acting on an object, acting on an object, and the time the net force acts on an object. On an object. Okay. So it's the product of the net force acting on an object and the time taken by the net force to act on that object. Ngamanye amazwi ke, sometimes we say impulse is the object's change in momentum. So in some special cases, you are allowed to use that definition whereby you can say impulse is the object's change in momentum, because that's what it is. It means that when you're not given a net force in exams, and also when you're not also given the time, let's say you're not given the net force or time, then they say calculate the impulse of the object. Well, remember, impulse is the same as the object's change in momentum of the object. So it means you can use the formula for a change in momentum to calculate the impulse of the object, which would be the mass into final velocity minus initial velocity. But you will see how we apply this formula, no worries. So this is the definition of impulse. Now let's move without wasting time. Now 4.2 says calculate the change in momentum that the car experiences. Well, we can calculate the change in momentum of the car if we know its initial velocity, of which we do. It's the initial velocity, we know the final velocity, and also we know the mass of the object. So let's just calculate the change in momentum of the car, which is also the same thing as impulse. Okay, 4.2, the change in momentum of the car, which is also the same thing as impulse, is going to be equal to mass into final velocity of the object minus its initial velocity. So that means that we're just going to substitute a mass here, the object, and the final velocity and the initial velocity. So the mass of this object is 1,100 kgs into the final velocity. We said it's 0. The initial velocity was, just go back to the data. The initial velocity was 4,674. 4,674. And then we get an answer of 51, okay, 5,141. So this is 5,141 0.40 kgs meters per second. Those are the units of a change in momentum. Okay, now because our answer is going to be negative, remember 0 minus 4,674 is going to be a negative, then a negative times the positive 1,100 will give you a negative 5,141,40. So that the minus sign means direction. We know that. That's why we're choosing a direction originally. Um, we chose direction and we said that west is negative and then east is positive. So that means if we do get a negative answer, that would mean that the change in momentum is to the west. In other words, it's 5,141,40 kilograms meters per second to the west. If the answer here too was positive, then we would say to the east. I hope that makes sense. So this is just a matter of choosing the correct formula, substituting the correct value with the correct signs, meaning using it direction, of course, and then just substituting and using your calculator for money answer. Okay, 4.3, calculate the resultant force on the car during the collision. So resultant force means F net. Okay, remember, you already know all of this. You already know the theory. Remember, we said that if you want to find the net force topic in this topic of momentum and impulse, the net force is equal to the change in momentum of the object over change in time. So in other words, the net force is equal to the rate of change in object's momentum. Okay, what do we have here? We already know the change in momentum of the car, which is impulse. We already know that it's 5,141,40, and the time taken by the net force to act on an object. Remember, ngoku collide the object with the wall or with the obstacle, it took 0.2 seconds to come to rest. So it means this is the contact time. This is the delta t. This delta t is known as the contact time. Mamela, as I believe you already know that. Okay, let's just substitute the 5,000. Remember, it's negative 5,141,40 divided by the time taken is 0.2 seconds. And then we punch our calculator and try to get the answer. Okay, when we use our calculator, we'll see that the answer is 25,000, oops, sorry, not 27, 25,707, comma 40. No, no, comma 00. You can also use your calculator to confirm this answer. It's 25,707 newtons, comma 00, of course. Since the rules is the exam, city round off to two decimal places. So we are saying comma 00. Maybe you may not have that comma 00 in your answer. You don't have to. Okay. Now remember this is negative. The answer is going to be negative. Remember, since we have a negative there in the numerator, so the final answer would be negative. So the minus sign means direction. Remember? So that means the net force is also to the west. That is why the object finally moves to the west after it collides with the wall. He end up I see a left because the net force is in the direction of is the opposite direction, which is west. Hope that makes sense. Let's go to the next question. So the next question says, okay, there's a statement before the question. Luckily, the driver is not injured during this collision. It's because he's wearing seat belts and the car crashes into as the car was crashing into the obstacle. And also the airbags were deployed. You get that? Let's read again. Luckily, the driver is not injured in the collision. He is wearing a seatbelt as the car crashes into the obstacle. So une seatbelt yakhe ayifakileyo enxibileyo. So that's why engakhange alimale kakhulu. Uye wasurvive and also airbags were deployed. Okay. Now they're saying at 4.4, using the laws of physics, explain how an airbag helps. Okay, how can an airbag help reduce the chance of injury during a collision? Okay, so we know that according to theory 4.4, just to explain and give you an idea, umsebenzi we-airbag, meaning that the function of an airbag is to increase the contact time so that the effect or the impact of a net force decreases for the same change in momentum. So what am I trying to say? I'm trying to say that the airbag slows you down as you hit the dashboard of the car or as you hit the obstacle. It slows you down. That's the function of the airbag, to increase the contact time. When you increase the contact time, the effect of a net force will decrease because F net and change in time are inversely proportional. Look at this. F net and change in time are inversely proportional. So when you increase the change in time, it means when the contact time increases, the effect of the net force will decrease because these two variables are inversely proportional. So an increase in contact time causes a decrease in net force. So the function of an airbag is to increase contact time. So let's say, because they are saying that, explain how an airbag is able to reduce injuries. So we're saying that airbags increase. So airbags, they do what? So wait a minute. Sorry, guys. Airbags increase contact time. Increase contact time. Okay. So if they increase contact time, how does that help? This causes the net force to decrease. This causes F net to decrease. Meaning the net force is our decrease, so meaning the impact of the net force will decrease for the same change in momentum, meaning for the same impulse. This causes F net to decrease since in net force the change in time is inversely proportional. In other words, since F net and change in time are inversely proportional to each other, it means when one increases, the other one will decrease. Okay, if net force decreases, it means injuries will be less. There will be less injuries. So in other words, therefore, or thus, there will be less injuries. Will be less injuries. Okay, this just so you know, guys, this is the same thing that dancers do. You see, dancers when they land after jumping, after when they land on the floor, they land on their toes first before their heels, so that they do not feel more pain on their heels. Because if you land with your heel, you will feel pain. The same thing happens on abantu abadlala i-netball. You see netball players or basketball, they always try to land on their toes first before their heels. This causes an increase in contact time. As they increase the contact time, it means they will experience less pain or less net force as they land on the floor. I hope that makes sense. They always try to ask you all those questions, how a dancer is able to feel less pain on on their heels. So it's because of the fact that they land first on their toes as to increase contact time, thereby reducing the impact of pain or injuries. I hope that makes sense, guys. This is all for this question paper. I'll see you on the next question paper. Take care.